But yeah, so here we go. 7.1, 7.3 exponential word problem. So how are exponential functions a part of our lives? How are they utilized? Well, here we go. We're going to find out. The number one way that we use exponential functions in our day-to-day life are when we're modeling growth and decay situations in our world. So right here is one of our most commonly used models for growth and decay. It's our interest formula. So if you look here, each piece has a value. So your A of t is your amount after the time period. Your rate is your growth or decay. If r is greater than 0, then it's a growth. If r is less than 0, it's a decay. Your rate is always written as a decimal. Okay, it's always written as a decimal. It's going to be given to you in percent more than likely, and you just got to be able to convert. Okay. Your lowercase a is your initial amount. Sometimes you'll see it as a P, but A is our initial amount. P for principal. I always mess up on which principal I'm supposed to use. Principal, I think it's it. I think there's only one. I just don't know why I said that. And then T is the number of times that it's going to be that it will happen. Okay. So we're going to be using this for the first 3 examples, and then we'll keep going. So example 1, you put $2,000 into a college savings account for 4 years. The account pays 6% interest annually. So after 4 years, how much money will you have? Well, we're going to establish what our variables are. So we know that from here, our A, our initial amount is 2,000. Our rate equals 6%, which has to be written as a decimal, which is 6.06, right? And the time it's in there is for 4 years. So remembering the formula is A of t equals A times 1 plus R to the t. So we're going to create the formula first. So A of t equals 2,000 times 1 plus 600 to the t. So A of t equals 2,000 times 1 and 600 to the t. Now I want to know how much will I have after 4 years? How much will I have saved in my savings account? So we're looking for A of 4, which equals 2,000 times 1 and 6/10 to the 4th power. Okay, so all we're going to do is go to Desmos. And when I type in my 2,000 times 1 and 600 to the 4th power, what do I get? 25.24, 95 cents. So I know that after 4 years, I will have saved $2,524.95. That's what my savings account will have grown to. So depending on the question, if it wanted to know the account balance, so this would be my account balance, then this would be the answer. If the question says how much interest occurred, how much did you earn? How much I earned would be the difference between the two. Does that make sense? So how much I've earned, I would have to subtract 25, 24, 95 minus my initial investment. And I would have earned over time 542. No. I put way too many numbers in there, y'all. I was like, what is that? There's an extra 4 there. $524.95. and this is what I've earned. So depending on what the questions ask, I would have to know, read it very carefully in order to know which response to give. But does that sound simple enough? Hopefully so. All right, so I'm going to give you one to do. So example 2, I'd like for you to try. Suppose you invest $500 in a savings account that pays 3 and 5% annual interest. How much will be in the account after 5 years? So how much will be in the account after 5 years? So I'm going to pause and let you try. Let's check and see how you did. So when you set this up, you should have known that your A equals 500, your R equals 0.035, and your T equaled 5. So you're looking for, after 5 years, what do you have? So you have 500 times 1 plus 0.035 to the 5th power. So when I go, I'm going to type that in. So I have 500 times 1.035 to the T, to the 5, and I have $593.84. How do we do? Good. So after 5 years, we know that it equals $593.84. Questions, comments, concerns? Cool. All right, we're gonna switch it up here. So using that same problem, we're gonna analyze, if you make no additional deposits, when will the account contain at least $650, okay? So at least $650. So using that equation we had, so A of T equals 500 times 1 and 35, but this time we don't know what T is. The key thing here is we're saying at least. So we're looking for at least $650. So when is it greater than or equal to 650 is what we're looking for. Okay, so we're gonna do this in the calculator, in the Desmos. So I go to my calculator, and I'm gonna put in the first part as a function. So I have y equals, well, we'll put f of x, I guess. F of x equals, and it's 500 times 1 and 3500ths. Instead of t, I'm going to put in x. I'm going to hit enter. Now notice I can't see anything, so I'm going to need to do some zooming out. Okay, and I'm looking for when does it reach 650? Let's see, sorry. Equal 650. So this is where I'm at 650, this right here. And I want to know when I am at least 650. So I'm looking for when do these two intersect? So after how much time? About 7.6 years is how long it will take. So when T is greater than or equal to 7.6 years. If I want to be a little more exact, 7.63 years. Do we see that? Where that came from? Okay. So according to our table, in our chart, we had that T has to be greater than or equal to 7.623 3 years. Okay, so that would be my answer. So notice how we put one function in and then the other function in, found their intersection and used the correct inequality. Questions about solving that one? So now they know how long they have to save. So if your goal is to get to 650, with this, how fast, well, how slow your money's growing, you can't touch it for that amount of time. All right. So in previous problems, not in this problem, I don't know why this came from a book. It was given that the function 150 times 8 tenths to the x power, where x is the number of years since 2003 and y is the population of the lynx. What will be the world population of Iberian lynx in 2020? Okay, so it's giving us the formula, the equation already. So we have y equals 150 times 8 to the x power. Notice right here that my b value is less than 1, right? The absolute value of my b value is less than 1. So what kind of function is this? Well, it's a decay. When our b value is less than 1, that lets us know that it's a decay function. So what does that mean is happening to the Iberian lynx? They're dying out, right? Their population is decreasing. They're dying out. And so it wants to know, how many lynx are we looking at in 2020? So this was created in the year of 2003. So in 2003, this is where we started. So in 2003, there was 150 lynx, is what this is telling us. What it's asking us is, how many lynx are in 2020? That's what we're trying to find out. So how many lynx are in 2020? Well, 2003 is my starting point. So 2003 is my 0. And then 2020 is how many years after 2003? 17, right? It's 17 years after. So we're looking for, when does this function, what is the value of this function after 17 years? So we're looking at f of 17. So if I have f of 17, it's just now a matter of me plugging it in. So how many lynx are left in the world after that time? So again, I'm gonna go back to my handy dandy calculadora and calculate that. So I'm gonna go and I'm gonna type in 150 times 8 tenths to the 17th power. And I get 3, and we're gonna say so there was 150 lynx in the world left. According to this formula, after 17 years, how many lynx are gonna be left? 3. You can't have a fraction of a lynx. So f of 17 equals about 3 and 3800ths. However, because these are people, animals, according to this, there would be only 3 lynx left with how they are declining in population. How do we feel about using exponentials for population analysis? Doable? Okay. And not all population analyses are decay. A lot of them are also growth. All right, the next thing we're going to analyze is giving information and finding an exponential function that best represents it, okay? Again, that's us using the calculator. So the best temperature to brew coffee is between 195 degrees and 205 degrees. The table shows temperature readings from a sample cup of coffee. How long does it take the coffee to reach a temperature of 100 degrees? Use the exponential model. So we need to create an exponential model in order to answer how long will it take to get 100 degrees? How long will it take for my coffee to brew to that? Okay, so the first thing we're going to do is create the table in Desmos. The second thing we're going to do is put in the exponential model. And our exponential model is y. I don't know what that symbol is called. Y sub 1 a times b to the x1. 3, we're going to use what a equals and the b to create our model. Okay, so those are the 3 steps. We're going to create the table in Desmos. We're going to input the expo model. And then we're going to create the model that fits the problem that we have. Cool? All right. So to put in a table, I'm going to hit add table. I'm going to type in my values. I have 0, 5, 10, 15, 20, 25, 30. I don't need 35. And then I have 203, 177, 153, 137, 121, 111, 104. So I created my table. And then I'm going to put in my model. So Y1, a tally. I don't know what that's called. Squiggle line. A times B. And I'm going to raise it. That's not what I wanted, but to the X1. When I raise, I usually just hit Shift 6 on the keyboard, if you're wondering. All right, so it tells me my A value, and it tells me my B value, and here is my function. So as I can see, it is a decay. So we have A equals 199, and we'll go with 2500, and B equals about 9800. Do we see where A and B are coming from, the parameters? So I can write my model. So my model is for temperature at time t, it equals 199 and 25 times 98 to the t. So it asked me, if I want the temperature to equal 100 degrees, how long will it take? So using this model that I have f of t equals 100, and I want to know how long is it going to take for that to happen. Okay, it's just like when we did the inequality, we want to look for the intersection. So we're going to graph this as a function, and we're going to graph this as a function and see when do they intersect. So I already have my model there. I need to know when f of x equals 100. So notice how when I type that in, it creates the 100, and I'm looking for when do they intersect? And they intersect after approximately what? 29.1 minutes. Do we see that? So we have 29.1. So my answer is T is approximately 29 minutes. Was that terrible? Pretty simple. So we created the table. We used the exponential model. We found our parameters A and B to create our model. And then we used our model to answer the question. Questions, comments, concerns. All right. Our last type of real world situation we're going to focus on is continuously compound interest. Okay. So what this means is that every nanosecond, second, minute, hour, day, week, month, you are continually earning interest. Okay. It is happening. Your money is working for you every second. And here's the formula that we follow. We use our natural log exponential, which is the E. So the formula is A of T equals P times E to the R times T. So we use this formula to calculate continuously compound interest. Our problem we have here is suppose you won a contest at the start of 5th grade and that deposited $3,000 in an account that pays 5% annual interest compounded continuously to the nearest dollar. How much will be in the account after 8 years? Okay. So in 5th grade, you won this super contest. Like, I don't know, maybe it was a book contest, maybe it was something, but you won a contest. So we're using compound continuously function. So we have A of T equals P, our principal, times E to the R times T. So for this problem, our P equals 3,000, our R equals 5%, and our T equals 8. So after 8 years, how much money have you earned since 5th grade? We take it, we plug it in. I'm going to go here, back to Desmos. I'm going to go ahead and clear all this out. And I'm going to type in, I have 3,000 times, let me get my, I think if I type it, it'll be fine. E carry 0.05 times 8. Uh-oh, I need it to be up there, times 8. Apparently, I need to put parentheses in order for that to work. And there's my value. So after 8 years, I now have $4,475.47. All right. So we have A of 8 equals $4,475.47. 47 cents. All right. How do we feel? Okay. So what you're doing is an activity on Canvas. So it's a word problem activity where you're creating table and graph. Feel free to use Desmos, but make sure that you are reading the instructions and following it out and filling it in completely.